recording going?
Yep, recording is going.
Yeah, awesome. Yeah, very well. So we can kick it off. Yeah, we have another EPF5 office hours here with another very special guest today. Alex, thank you so much for joining. Yeah, it's an honor to have you here. So yeah, I guess many of you, I hope maybe all of you know Alex, or at least heard of him, or at least saw some of the ACD that he's been running, maybe some of his work. Um, on the MEV, on the constant specs in Rust, uh, or maybe just heard of him as a co-researcher. Maybe saw the EPS, the study group talk that he did. So yeah, you're right, Dan. So I think you are familiar with Alex. And today I hope to dig deeper to give you guys opportunity to have some have some more questions for Alex to get him know better and explore some more parts of the protocol, consensus, and so on. But first, I want the fellows to get to know you a bit better, give some context, and learn a bit about you yourself. Like, if you can maybe before we get to the questions, if you can share a bit about your background, a bit how you get into Ethereum, what led you to this journey. Yeah.
Yeah, definitely. Yeah, thanks for having me. Excited to be here. Good to see you all. Hmm. Yeah, my crypto journey. I feel like everyone has a very like unique and interesting story, which is one of the cool things about being in the space. So, hmm, let's see. Let me think where to begin. Yeah, I mean, I guess I first heard about Ethereum just like on the internet, probably like Reddit or like Hacker News or something a very long time ago. And I was like, oh, this sounds pretty cool. Like I had been following Bitcoin for a bit, and yeah, this sounded like an even cooler version of Bitcoin with all these smart contracts. But I didn't really like, I guess at that time, I wasn't like as into crypto as I am now. So I found it like technically interesting, and it was like, yeah, like, definitely something that piqued my curiosity. But um, yeah, it was more kind of like a remote thing. And yeah, at the time I was working in like some tech startups. This was many years ago at this point. Um, but it just kind of got to the point where, yeah, I kept hearing about this Ethereum thing, and it really just got to the point where like I just wasn't even like thinking about my day job because I was just like thinking about Ethereum and like all the cool things that could happen. I think I first got nerd sniped like with yellow paper. Because I think, like you read through it, and then I think I got to the point, I think there's like an appendix, or at least there used to be, of like the precompiles, and I was like, oh, okay, like, you could imagine like enumerating every possible computation, in some sort of shared state like this. And that just like really fascinated me, like intellectually. So long story short, I guess I got nerd sniped. And then I was like figuring out ways to like, yeah, just get more involved and sort of navigate that. And really, how I started was just like open source work. I've done a lot of like engineering in the past, and yeah, it seemed like a good way to get started. Like I didn't really like know anyone or anything really about Ethereum so much, but definitely there was like many opportunities for like open source engagement. And so at the time that I like, started getting more involved with Ethereum, there was this notion of like ETH 2.0. And, fast forward maybe even like 4 or 5 years, and that resulted in the merge and how things look today. But back then, like there were many different ideas around how we do proof of stake. Like we were even at one point going to have a separate blockchain that would essentially be the proof of stake layer that would then just finalize the proof of work chain. So, point being there is it's interesting to see like how the research evolves and like how these things sort of, develop in time. But yeah, I think the like first concrete thing that I did was actually part of this proof of stake system I was just describing. The thing that we wanted was, I mean, so you've probably heard another context of account abstraction, maybe with like ERC 4337 or 7702 and things like this, where, we have like accounts on Ethereum today and they do some things, but you could imagine them doing a lot more. A very simple example is even just this notion of like a multi-call, where, when I make a transaction today, it basically just launches like sort of one set of actions. You could imagine instead that I want to do like multiple of these actions within like one transaction, simply because it might be cheaper or more convenient or yeah, just easier for me as a user to like do this. A good example is like if I make a token swap on Uniswap, right now you have to do this like ERC20 flow where you have to approve the thing and then you have to make the trade, and like this is just annoying. um, and so account abstraction broadly is like thinking about ways to change how accounts work on Ethereum so that you can, get better UX basically around these things. So you can imagine doing this approve and transfer in like sort of one transaction rather than two. So point being is there were similar ideas at the time around having account abstraction in this way, but for validators on in the proof of stake system. And what that would look like in this case is like right now we have the proof of stake system with the beacon chain and everything and Ethereum today, and we use this signature scheme called BLS. And the sort of desire at the time was to like also have like a sort of abstraction around the signature scheme. So you could imagine a validator signs up with whatever they want, maybe not just like BLS, but like it could be anything. And like concretely, anything that you could express in a smart contract. And so that was like my first open source contribution was um, we call it like the purity checker. Purity in this sense refers to like Notion in programming, where it's the fact that you want a piece of code and you want to make sure that it can't change the state. And the way this comes into the account abstraction bit for validators is that it would um, you basically need a way to have the validator register on chain. The validator could then point to some smart contract as their like signature verifier. And then what you just want to make sure as part of this registration is that the smart contract they point to was like pure in this sense. The reason why is because signature verification needs to be deterministic. You can't have like, you could even imagine something crazy where it's like, as a validator, I want to sign my proof of stake message and I want it to be conditional on like the token price on Uniswap or something, right? Like this is very possible. But token prices all over the place. And so, a signature might be valid at, today, but then maybe and say or let's say it's valid now, but then in the next hour it's not anymore, right? So this doesn't make any sense. And anyway, long story short, I wrote some code to do this. You couldn't actually do all of this in Solidity at the time, and I still think you can't. So I actually had to like drop down to EVM like bytecode, which is just like a fun way to like learn more about the EVM. And I ended up writing it in this like weird thing that I think actually Vitalik or someone wrote many, many years ago. It is like a sort of like high level language wrapper around EVM bytecode called, I think it was Serpent. This is like all very deprecated at this point, but anyway, it was very fun. It was an exciting way to like get more involved with Ethereum and the research and development there and get engaged. So I was doing that, and this is probably around the time, I don't know, this is roughly around the time with like DEF CON Prague, and I went to like DEF CON Prague and I saw like, oh, like there's such a big community here and like there really was something special. So that just kind of pulled me in deeper and deeper. Um, then that I think would have been 2018. So then I started the EF in 2019. I was brought on to the EF to work on a Python client actually at the time of this ETH 2.0 stuff. That client has also since been deprecated, but that was like a fun little arc. And yeah, then in the meantime, I've like drifted kind of between more research things, more development things. And yeah, from there you can kind of fast forward to Ethereum today. We have the merge that's happened. We have proof of stake now. And yeah, now we think about, the next phase of Ethereum's evolution, whether that's like scaling data or like censorship resistance or things like this. And yeah, maybe I'll just pause there. That was a lot.
Yeah, you went pretty into weeds and details there, but I really appreciate it. Actually, it's great. Thanks so much, Alex. I mean, you're also getting to the current state of things. Like, I'm wondering, yeah. So, what are you working on these days? What excites you now? What do you personally work on, but maybe just find exciting in the ecosystem? Yeah.
Yeah, I would say like around the time of the merge, like very much like MEV had become a thing, and it was like something that everyone sort of we all sort of realized was like a thing, an issue on Ethereum, and that we need to like focus on it. So I would say I like kind of got nerd sniped by MEV as well. And the angle I approached it from was more like consensus security. Like I guess that's kind of always been my thing. Is I was like, okay, we're gonna have this new consensus protocol for Ethereum, like thing that we must ensure is that it's secure, right? Like when we think about blockchains, like what is a blockchain good for? It's good for getting these like commitments basically in this like, decentralized or like credibly neutral way, which maybe we can jump into what that means. But ultimately, like you just have the system that gives you a set of facts, and sort of the guarantee that you have is that no sort of single party can like change the facts on you. And as long as you have that primitive, you can build all of this stuff on top, whether that's like tokens or like stable coins or DAOs and like different like governance innovations and experiments, like and this sort of then points to all the crazy stuff Ethereum can do and like everything you can build on top. So point being is you need to make sure consensus is secure. And yeah, so that's kind of, I think, the frame generally with like my work is just like making sure that Ethereum is secure. um, Separately, now we need to think about, is Ethereum scalable and all these other questions. But yeah, so because of that, yeah, I've done a bit of stuff with like MEV, especially with respect to like infrastructure and like the protocol level. um, and then what that looks like today is like I talked to like a bunch of these different relays, a bunch of different builders and like teams in the ecosystem there. And yeah, I mean, I think over time I've kind of shifted my work to more of like a coordination role, simply because it's really important in a space like ours. And yeah, so like lately, I've been pretty involved with like, yeah, all core devs and yeah, just I guess engaging with like the AP process and the governance around that.
Yeah, awesome. Yeah, it's a lot of things that Alex is touching. So if you guys have questions about any of those, feel free to raise your hand. Feel free to ask. I see we have a question in the comment, but if you just want to read it, Katya, feel free to speak up.
Yeah, hello. I can just ask this question. Yeah, this question, I can hear it a lot, like discussing it, and many people concerned of it. How to avoid stake in monopoly? Yeah, thank you.
Right. Yeah. So it's tricky. So the question here is, I don't know, Dan, did you want to hop in right now?
No, it's queuing for later for
I'll
more
Okay, okay,
questions. Yeah.
okay, cool. Right. So what this is getting at is that, so we have this proof of stake system today, right? We have this like notion of a validator, and these again are these protocol actors that are providing this like, I said a few minutes ago, let's say, this process of finality, and like really this is where we get the security of Ethereum. When we say finality, what we mean is that once this like consensus process has happened, and it's this thing that's continually happening, but once it has done its thing, you get this guarantee that some amount of the stake of like the ETH that is sort of bonded to secure the protocol is basically saying, yes, this is the canonical chain, and there can be no other chain. And moreover, you have these like very strong sort of, we call them crypto economic guarantees around the fact that if there is some, malicious behavior with respect to this guarantee, there's like steep penalties you can apply. And so that's all well and good. The interesting bit, of course, is when sort of theory hits practice, so to speak, because now you have the system. The way that you incentivize validators in the system is you like give them rewards for their behavior, and that's all well and good. But then you get to this situation where now there's almost this like financial element where you get paid to stake, basically. Um, and this, I guess, is a kind of double-edged sword because now, people are directly incentivized to do this. Like people even then start to see like staked ETH as almost like a financial product or like an investment. They start to go and do all this stuff. And what happens then is, it almost becomes competitive where if I'm sort of better at operating my validators, I can maybe get a higher yield. And this then kind of circles back to like MEV and like now with restaking and like all these sort of things where, and then again, this is like a very cool thing about Ethereum is it is so like flexible in general is you can build all this stuff on top. Now, the thing then is that these like other applications kind of funnel back into the core protocol and have direct implications for how it looks like. And like in particular, what can happen is, again, as a validator, like as an operator of like some amount of the stake, if I'm better than others at doing my job, then basically I can you can imagine I get higher returns. I can then invest that money back into getting even better, And then this is where we get to these like centralization vectors. And this is what you'll hear people talk about all the time. Because yeah, basically more sophisticated operators can do better, they do better, so they have, more resources to get even better. And what that means is that if I come to the protocol, I can imagine maybe rather than running my own sort of, node at home, I want to go with one of these big operators because it's simpler, it's easier, and they'll just give me, more money if that's the thing I care about. So if you play this process out, you get to like a very sort of concerning end state where, you can imagine there's only one or like a few like very big operators who like just do this professionally, and then all the stake sits with them. This is a problem because it directly goes against like this core value of blockchains, and which I said a second ago, right? This is what we want, is we want this ability to have these like very hard guarantees around like the commitments we make. Say the Ethereum protocol state at point, yesterday was this, today it's this. And the issue is you start to erode these guarantees the more centralized, this sort of the set of operators of the protocol is. And this is like the monopoly here. So when we talk about this stuff, this is why it's a problem. It's tricky because there are just like natural, there's this notion of like economies of scale where basically this is just, you see this even outside crypto, outside of Ethereum, proof of stake. It's just this is everywhere in the world that usually, many things are just cheaper or easier to do if you do them bigger. And so now there's this tension between, this like phenomenon in the protocol while still preserving this like core value or like property that we want. And yeah, so how can you avoid it? Well, it's very tricky. There's a lot of research around this topic. Many people think about it. I think the most like probably the most like compelling answer is just changing the actual staking economics where this is no longer an issue. And maybe even before I get there, like there are other ways we've thought about like sort of isolating these different concerns. So maybe this is a better point to start actually. Like, so these economies of scale exist. And so you could say, okay, what can we do about them? We can either say, okay, they're here and we just accept it as a fact of life and move on. Or we can say, okay, are there ways to like isolate it in various senses so that it doesn't have impacts on like key parts of the protocol? And if you follow any of the MEV stuff, or like you probably heard PBS or like proposer builder separation, this is like one way to like have this separation. So, I said MEV is like one of these domains where more sophisticated actors can, more readily take advantage of these economies of scale. And yeah, you could very much just, it's actually like kind of a crude idea. You just imagine splitting it off in some way. So like if MEV is a problem, just try to like silo it away from the validator set. And this is exactly what PBS tries to do. So that's like one answer. There's more speculative research around like, you might have heard of like APS or like a tester proposer separation. And this is kind of even going a step further. So like with PBS, we separate out this like execution builder role. And that's kind of where this whole MEV domain sort of lives and is generated from, separating that from the validator. You can then imagine there's even now a notion of like a testing. And again, this is kind of getting down to the weeds, but as part of this process of the proof of stake consensus, you perform this duty called making an attestation or a testing. And you could even imagine then separating out the proposing role. So like the role of building blocks today and actually like getting them on chain, you can separate that out from a testing. And so you can imagine then in like, as we go through time, there might be ways to like carve up the protocol in a certain sense that, isolates these more problematic issues from the very like core parts of the protocol that give us, again, these guarantees of decentralization, of social resistance, and all of this via testing. So that's one way. The other way that I was kind of hinting at a second ago is like more economic. You can just try to change like either the reward schedule of the protocol or like the ways that the incentives around being a validator in the first place that might naturally also like sort of put back pressure on this like tendency to monopolize. And there's a couple different ideas around this. I mean, one thing is you could just imagine making it less attractive to stake. So you could literally just like lower yields. And that's like a pretty simple solution. But then again, at the same time, we want, like, the reason there is this like notion of yield in the protocol is to attract people to stake and to actually secure Ethereum. And so if it's like too low, then maybe we don't have enough people securing it, and then you start to harm the crypto economic security we have. So that's an issue as well. So yeah, it's not quite clear what to do. The other thing here that's worth mentioning is just that you could imagine other ways to think about how the staking actually works and like in an economic sense. And this is where something like stake targeting comes to play, where what we mean by this is basically say, okay, regardless of what the supply and demand is to actually like stake and secure the protocol, you can just say, there's essentially an in protocol target, let's say, of we want this much stake. Say 20%. We want 20% of all ETH staked, just for like a random number, for the example. There's a way to like have the protocol work where it looks like this, and then how that would like look like in practice for like a staker is that, let's say that there's less than this 20% number staked, then like yields are higher, so then people are incentivized to come join and participate. If it goes above the 20%, then basically yields are actually negative, in the sense that like you're paying to stake. And in this way, you can like tune the protocol to like have an equilibrium around whatever this target is, the stake target that we have. I mean, yeah. So how does this help with monopolies? Well, the first thing it does is it has this like pretty hard constraint around only so much ETH staked. Again, the like sort of pathological scenario is you imagine all the ETH is staked and it's all staked with like one staking operator, say Lido, not to pick on them, but just for example. We want to avoid that, probably. And there's very much an active debate around all the nuances here. But yeah, so you have it in a way where even if there is sort of a monopoly of staking operators or these staking pools, you could imagine constraining them to like some subset of the ETH. And so then you have like, say 80%, if our target's 20%, then there's 80% that just is not rational to stake. And so then it's available for other purposes, whether that's for like more money purposes or for use in DeFi or, buying NFTs or like whatever have you. So yeah, long story short is it's definitely a tricky problem. There's like a lot of rich research around how to handle this, and yeah, it's not super clear, honestly. Like I think there's many directions to go in, and there's very much an active debate around what's the right way to do this. Like as Ethereum grows, like more players come to the table, it then starts to become a very political sort of, question, because at the same time we could say, oh, maybe economically or like if we zoom out, like some stake targeting regime makes a lot of sense. But then that's directly basically telling these staking pools like, hey, your revenue is capped, which like they don't like, right? So it then becomes not so much a technical conversation, but a different one.
Thank you.
Thank you so much, Alex. This was a tough question to start on. Went from like 0 to 100 pretty
No,
fast.
it's a good
But
one.
yeah,
Yeah.
yeah. Thanks for elaborating on all of that. Yeah, yeah. It's been a tough discussion, and I'm sure that Dan has something related.
Yes. Not to ease the whole topic, which was very well brought up. So in the context of not of the economic part, but of separating the validator role with EPBS with APS, my EPF project is EODS, operator enshrined operator delegator separation. So it's basically a conceptual design and hopefully a specification of introducing delegations in protocol and separating capital providers from node operators. And the specific question would be if with your expertise and knowledge about Ethereum, what would be the validator attributes from the current action set that could be considered not strictly related to finality, so not strictly related to bringing economical security, because at least in what I'm prototyping with EODS, that could be abstracted from the validator set and added to a delegator set that could back a network of light validators, bringing security on chain with censorship resistance. But there are other roles, like, I don't know, whistleblowing, for example, so can you I'm trying to pick your brains on this, if you can help me, because this is the point of my project, where I identify these attributes that we could consider removing from the validator set and moving to the light consensus, so to speak.
Right. Yeah, and so yeah, it's nice that you brought this up. I think that's another, actually good point to my previous answer around like
Exactly.
what are ways to think about this. There's this notion of like rainbow staking from Barnaby Monroe and like some of the rig team, and
Yeah,
right.
Barnaby is
So
my mentor. Yeah.
okay, great. And so yeah, maybe just to like briefly explain what this means is like, yeah, it's a kind of taking this notion of like, okay, can we sort of analyze the different parts of the protocol and imagine ways to like maybe unbundle them and like rebundle them in another way to address some of these centralization vectors. And so right, you could imagine that you have like even like a very lightweight sort of validator set that's maybe even just doing a testing or something like this. You could even maybe go a step further and say there's even like validators who are just doing like censorship resistance functionalities in terms of like just doing inclusion lists or something like this. So, we'll see. Like, it's very interesting research and I think very exciting. At a high level, there's a tension between things being like too complicated, basically, because like the more complicated the protocol is, just the more hard it is to secure. And so, yeah, I guess just
There's
something to
no
keep in
clear
mind.
path. There's no clear path
Yeah,
ahead.
yeah. But then to answer your question, so there's a couple things. I mean, we can go down like the PBS route of taking out like execution building. We can go to like the APS world where now there's like an execution proposer and that kind of subsumes PBS. Then you have a consensus proposer, so like that's kind of a distinct thing, is proposing like the consensus block. Another thing then is like the role of the testing, where this is also kind of the APS world, where it's like you then take out like the consensus functions from even proposing blocks in the first place. There's like a few other minor duties that you could at least think about. One of them is like sync committees. So like there's today
Exactly.
we have validators who like basically provide the infrastructure for light clients, and that's like a different thing that you could imagine pulling out as some separate thing. Um, yeah, and then yeah, like I think it also would be worth thinking about like any sort of like inclusion list design or like some CR design where like that could even be like a separate task that like validators sort of opt into. And yeah, I mean, even when we put it like that, it kind of points towards restaking, and then you could even start to imagine like with some ODS thing, it's like somehow starts to even enshrine like these different like restaking ideas people have. That's like all kind
Yeah,
of worms, but it's an interesting
like an
line of thought for
AVS,
sure.
like an in protocol AVS somehow,
Yeah, I
like a
mean, so Mhm.
like a delegator stake delegating value to a node operator that participates in finality and gets some sort of a liability proof that he delegated, and then uses that to back a light operator that's non-finality, so non slashing,
Right.
so to speak. That's some sort of
Yeah.
restaking.
Yeah, and like something else this kind of makes me think of is like another use case that would be interesting is some sort of like native LST where like you could imagine like you pick apart, yeah, the right parts of all these responsibilities in a way that you can now have people like have their own LST. And so this is the whole thing. Like this is, I guess, even another point of like how do you avoid staking monopolies is like if the issue is these like big staking pools with like their own sort of bespoke LSTs or like their staking derivatives, you could imagine having this in the protocol somehow. This is tricky because the whole like the reason LST is like coherent or makes sense is because there's like a similar risk profile with respect to all the validators that the LST represents. And so then if you imagine a world where like any validator can make their own LST, then like there's no way to know right off the bat like if they're fungible at all. And then it is not a useful sort of construction if there's like a million validators and a million like everyone has their own LST.
Clearly,
Um, yeah. So I don't know. I've thought about some things around here, and like Dankrat, I think had some research. Mike Noter had some research around this like two-tiered staking idea that I think gets in this direction. So yeah, that's worth looking at. Another thing would be, yeah, like I mean, I even had the idea of like you could imagine like a Uniswap hook that takes a proof of like validator performance, and then that is then like somehow rating like the risk profile of a certain batch of stake, and then you can imagine that's like underwriting an LST, and then from there, yeah, maybe you would start to get like buckets of things, and you start to have some like even sort of more decentralized LST than what we have today.
Potus proposed something, but it was in the EPBS context of clients building their local rating system for builders. We could also, I also consider some idea of having a validator rating system that the delegator can, opt. So I want to delegate to who, what validator, what node operator. So we could have like a rating system and then just go with the validators that do not work with censoring builders or with timing games playing builders or stuff like that. Yeah, it's
Right.
going into the weeds now. So just for my own reiteration, so it's you said sync committee, something that it's absolutely not related to finality. Whistleblowing,
Yeah, that's an interesting one. Like you
because
have to
that's
think
not
about the
allocated.
incentives. Right.
Yeah.
Well, it's more just like anyone can do it. And like, yeah, there is this sort of like dilemma of sorts where it's like, yeah, it's not really incentivized. Well, okay, so you do have like this whistleblower's reward, but like, you could imagine that like no one's running a slash around mainnet. And like that like I don't think it's the case. It's not the case, but you could imagine it is. And then that's like kind of a huge hole in the security model. So yeah, I don't know. Maybe you could imagine some like part of this ODS service that's like, yeah, somehow incentivizing more directly or more strongly, like this whistleblowing
and
thing.
inclusion list, that's the first major stuff, obviously.
Yeah.
Okay, Alex, thank you. I don't want to take too much of the fellows' time.
Yeah.
Thank you very much.
Yeah.
Maybe we
Yeah.
can chat on Discord more.
Sure.
Thank you.
Yeah.
Thank you both. Yeah, we dived pretty deep into the consensus there. I wonder if anyone else has a question related, or maybe to switch topic. Yeah, Pella.
Hi, Alex. My question was more on your role as a coordinator for these all-core developer calls. What your like biggest takeaway or most surprising thing about development in Ethereum compared to your more traditional role starting in startups?
Yeah. Okay. There's a lot. I think the biggest thing is just like understanding and like having experience with how like open source development works. And it's just like such a different frame of mind from like everything else you'd see in like more traditional context, like a for-profit company or like a VC-backed company or something like this. And some of these things maybe are specific to like crypto or like blockchains and how like Ethereum works, but at least how we do have it on Ethereum today is like you have a bunch of different people. They have different interests and different reasons for being here. And so yeah, like that's great because you have like more perspectives and like just more engagement and like the system overall is more resilient, like the more actors there are. But at the same time, there's not perfect alignment and then there can be frictions there and like those can be interesting to navigate. So yeah, I think just like understood, like seeing the system, having some view of it at like a high level is like very interesting just to like see over time, like how different decisions are made or like why they're made and how that plays into everything. Yeah, and especially in like a context like this where it's like very decentralized, like a lot of it just feels like cat herding sometimes, where it's like people usually like, generally there's like reasonable suggestions made saying like all core devs, and so it's not even so much that like it's not even so much about like needing to make a decision. It's more just getting people to even pay attention in the first place, which I guess is like, yeah, I guess the point here is just like attention is finite, and yeah, it can be hard even just to like know that someone's even like seen a proposal, let's say. So yeah, that's pretty interesting. And yeah, I don't know. I mean, I think that's like the biggest thing is just like the scale of the process, the scope of the process, and like seeing how it plays out. And yeah, again, both like in a very nice way because you see there's like so much like interest and engagement with Ethereum. And then yeah, at the same time, it can be yeah, there have been some spicy ACD calls. Like Pectra is a good example where it's like, the fork is probably too big and like we need to do something about that. But then you ask different people and they're like, yeah, well, we think EUF should be in for these reasons. We think, MaxEB should be in for these reasons. And then like no one's wrong. It's just more a question of like scheduling almost, where it's like, what's the sort of highest priority thing and like when do you do these different things? Um, yeah, so yeah, it's fascinating.
Thank you.
Thank you. It's interesting. I'm glad we could ease out the topic a bit. Guys, please raise your hands, otherwise I will take the opportunity of questions for myself. Yeah, Katya again.
Yeah, my next question won't be so tricky. Just about my project, I'm working on PeerDAS metrics. It would be nice to hear your opinion. Is it possible and does it make sense to standardize metrics across clients?
Yeah, no, it definitely makes sense. Like it'd be super valuable. This comes up in many different other contexts, like even just like the JSON RPCs, for example, where it's like, we want anyone to be able to use any client, again, for like security reasons, because we have this like very nice sort of multi-client security posture. But then if you like go to use one client and they have some nice RPC feature, if the other client doesn't support it, then like that's not nice. So generally there's like a lot of value in standards. And similarly with like metrics where, there's things that we all want to know about with respect to like, I don't know, if I'm a validator, I want to know like what my attestation performance is. And so like, I think at this point, all the CL clients expose this in some way. Some even have like very nice dashboards with like Grafana and these different like metric systems that are really nice. So yeah, then you could imagine the same thing for PeerDAS and like different things like that. And so then you want to see like, even just knowing like bandwidth consumption and like, when I'm going to sample sort of this column or that column of like the block that, is it happening? Like how much bandwidth am I using and things like this. Something we'll probably see is like some ability to like customize how much data you're downloading like under PeerDAS. And so you could imagine like maybe you have a default setting for like a solo staker where they're only downloading like the minimum amount of data required for security. But then you might actually say, for example, say you're like an L2 and you actually want the blob data in its entirety, you'll probably need to subscribe to like a majority, if not all of the subnets. And so again, like having metrics around what your node's actually doing with respect to like your preference here is like super valuable. So yeah, it'd be really nice.
Yeah, thank you.
Yeah, nice. Anyone else? Maybe feedback for the project or any other question?
There's one in the chat here. What implications would standardized metrics have on attacking the core protocol? Hopefully none. But it's like it's good to think about. Like nothing with metrics, like nothing really sticks out with metrics, but there are things where like you can imagine like even like again because of like the Ethereum process being so open and like public, you could imagine that like someone here is like looking at something with like some client and they realize that there's some discrepancy between like how client A processes blocks compared to client B, and in the limit this could actually be like a DOS vector. And for example, if it is a DOS vector that's like on mainnet, you don't want to just like go to Twitter and like broadcast this, because then we would have chaos. Someone would then go and trigger it on mainnet. It would be like a whole thing. So I guess that's like important to say, is just like try to have this like adversarial mindset kind of throughout everything you do, because you could find an issue and very much it needs to be fixed, say by like the developers of this client. and it could be multiple clients. But either way, there could be something here, and so it's like good to keep that in mind. That like, yeah, like we're on the bleeding edge. The software is like very dynamic and in flux, and like there are things. And so if you find something, maybe at least be mindful of the fact that it could have like very big security implications, and so that just needs to be like managed appropriately. Yeah. Otherwise, with respect to like the question, like standardized metrics, I don't know. I feel like the things you'd standardize, like I guess one is that they just have enough scrutiny. Like otherwise we wouldn't have agreement on them being standards. So like it's things that people feel like, they've been looked at a lot, so they probably don't have these sort of security considerations. And yeah, like metrics are very sort of like, it's more just a description of what happens. And so I could imagine a scenario where like metrics show you, like maybe they call your attention to like some issue. But yeah, I think otherwise it's pretty okay.
Maybe more of a JSON RPC, like some debug namespace, which is also used for some similar things, like metrics might trigger some heavy computation. That's a DDoS vector there, like in these sort of things. I cannot really see the metrics there, but I like what you said there, like think about security implications of everything you do, like, any change in the client, basically. Yeah. Sure, if you wanted to elaborate on that,
not elaborate per se, but like there are these attack vectors that nobody executes, like nobody attacks using that, like specifically targeting validators in the current Ethereum network, right? Anybody can do it, but nobody does it. That's another scenario. But I just think that with metrics, linkability of identities on the blockchain would become much more easier, and I think it would open up. I'm not sure if it would, but it feels like more information taken out would allow me to link identities to Ethereum addresses and like directly target them in a sense.
Right. Yeah, and you could imagine like some pure DOS metric, for example, that maybe I get some data on like which columns I get from which peers at a particular point in time, and then you can actually use this to then like correlate validator identities to particular nodes, just given the way that pure DOS works. And yeah, this would start to like give you this information to like have this linkability. And then, like if you have the IP of a validator, you can just wait until it's their turn to propose. You could even like on demand DOS them. And then suddenly, there's no block for that slot. And like Ethereum has gone down in some sense. So we definitely want to avoid this. And like validator privacy is a big thing. People definitely think about it all the time. And it's just kind of one of these like cat and mouse games where like you just need to kind of be ahead of the attacker and just keep it in mind.
Like it's much broader issue of the validator privacy. Like, metrics are generally used locally, like it's some endpoint on the client that you listen to with Prometheus InfluxDB and you just follow what your client is doing. It's just it's like logs of your client, but more verbose basically. So, but the general privacy of validators, like what Alex said, like the IP addresses and or the validator keys are all public. It's all linked to your deposits. So it's not ideal right now. Like I we haven't seen any attacks so far. Like after so many years without any attacks I can think of, like maybe it's just because it's secure. Like somebody had to try at this by now, right? I don't know. Any other question, folks? We have still 10 more minutes to go. I had a question earlier, going back to the monopolization, to the pools and stuff, because a few months back there was the proposal on the attester penalty, the correlated penalties, which was pretty. I don't know, like it was pretty cool at the time. I remember Tony had a feedback for it, and there was a conversation going a couple of months ago, but I'm not sure if it's still happening. I'm not sure how it what is the current state, whether it's still active research or what do you think of that?
Yeah, no, I mean it's really interesting work. The idea would basically be to like have yeah, let's say like additional penalties if you could like detect correlation within the protocol. Um, and the way you'd start to do this is you could actually look at attestations on chain and then start to understand like, you know, essentially if some group of validators like moved in unison with respect to like their attestation behavior. And then in doing this, you could then pretty confidently say, oh, well, they're probably like a single unit. And then if that unit has like some, you know, say they like, uh, you know, miss the head of the chain in their attestation or like attest to something that is non-canonical, then you could actually like penalize them even more. And that's like the correlation penalty. And the idea here is to have this, it's like, it's not really an incentive as much as it's a disincentive to like have like a shared setup, right? So to not correlate. And yeah, no, it's definitely interesting work. And you would imagine that, you know, the success case is one where now as an operator, you have to think about, okay, even if I am operating many validators, I still want to have them in some decorrelated way to avoid this penalty. And, you know, that could look like, say, I'm Coinbase and I have a lot of like validators that I run. I could imagine putting like some even across different like AWS domains or like different data centers, even across different continents. And there's like all sorts of things you can imagine around like resilience here. And then, you know, on the margin, this like goes all the way out to even like home stakers where it's like, sure, as like a home staker, you're probably fine. Imagine though that you're like staking in like New York City and there's happened because you're in a high population center, there happen to be many other solo stakers with you. So like that's like an interesting thing to think about. And then if you're like a solo staker in like, you know, some random city in like Brazil, like, yeah, I don't know, Brazil or somewhere like say South America, like you know, you're probably fine here. And then as part of the work there with like that EIP or like the proposal is to figure out like the right parameters to tune it such that like you don't overly penalize these like very uncorrelated people while still having this like sufficient disincentive for these like sort of bigger scale operations.
Yeah, awesome. Thanks, Alex. Yeah, it's great to hear that it's in progress. It's been a couple of months since I last heard about it. So thanks. Dan has some more questions.
Only if there are not other questions from fellows. I just had a question popped up. So MaxEB and what follows after MaxEB? So we get some reduction of the validator set. We get consolidation. Yeah, I reckon that's something that we all should be looking forward to.
Yeah, I think so. I mean, one thing even already is like there isn't like a strict incentive. Like there's not a clear benefit necessarily to consolidate. Like there's no in protocol rewards for consolidation. So like that's interesting. Um, you know, the people working on this EIP have definitely talked out to like reached out to the big staking pools and like at least given everyone like a sort of soft, you know, thumbs up that they will consolidate. Um, but yeah, like that's an interesting bit. And yeah, I mean, what's next? Hmm. So, I mean, I guess there's a couple of things. One is it kind of lines up SSF work, which is like really exciting because with the smaller battery set size, it's much easier to like do like to get actually to finality within a single slot. SSF, that's what we mean. So that's pretty cool. And yeah, there was something else, but I just lost it.
No, I think SSF is. I think this was where I was also thinking about, and Fradam's orbit SSF, and that
Mhm.
tackles the consolidation, you know,
Right,
reward, and,
right.
but and again, just high level discussion. Does Max EB get us one step or two steps closer to SSF? Because we see SSF as a future event in the far future, but it just might be closer than we think, or not.
I think it is closer. I don't know. Like SSF is this thing where like at least in like the research community, we've been talking about it for like even a couple years now. Like even this year myself, I've like been like, oh, I need to like change my perception of this because like I think it's actually much sooner than like sort of what I at least I was thinking previously. Especially like orbit and things. Like I think there's parts of SSF as a vision that we can start to do like in the next couple of years, definitely. That give us a lot of like nice benefits, and like yeah, it's I think very much more accelerated timeline wise than yeah, at least that I was thinking even over this year, let's say. So yeah, super exciting there, and yeah, we'll see. We'll
Yeah, great.
see
Thank
what
you.
MaxDB does and how much people consolidate, and yeah, that'll just kind of tee us up to make SSF easier to ship.
Yeah, awesome. Bastin?
Hey, yeah, thanks. So I wanted to get your thoughts on like the current state of light clients and what the future could look like, and what's like missing in your opinion right now.
Yeah, this is a good question. So light clients are good because, you know, we like the end state of Ethereum is like, at least what I would like to see is like this ability for like a very heterogeneous set of nodes to like engage with the protocol, right? So you could have like maybe these more professional, like very big operators who like are offering the service to like either produce blocks or like, you know, perform the staking function and like come to consensus and things like this. Separately, you then could imagine like sort of smaller actors who still want to like both sort of read and write the chain. So that's like both validating the chain and knowing like which, you know, if there's like some state root or like block root of the state of the chain right now, that it's valid. But then also like interacting with the chain in the sense that like I might not necessarily want to like run a full node to like send my transaction. And there's a lot to say here. Statelessness is like a whole thing that's like very relevant on like the spectrum of like node capabilities. That's very exciting with like Verkle and things like that. And then you get into like I think what people more traditionally think of with like clients, where you know you could even imagine that like you know MetaMask or like Ravi or like whatever, like your wallet actually has a light client in it, and this is you know a huge improvement on the trust model today, because like if you go to use MetaMask, you're basically just trusting consensus that like the chain is what they say, and like when you go to make a transaction, like everything checks out. You know, very obviously then this is like a single point of failure, and kind of, you know, it's not the best way to interact with Ethereum. At least like we can do much better. And the way we do much better is by having, yeah, we like take more and more of this like sort of sovereignty almost like into the end user's hands. And the way you get this with like is with like clients. So they're super important. And yeah, I mean, where are we at? I mean, I think a lot of it is just kind of blocked on even getting wallets to start to adopt these things in the first place. There are some like protocol things, like again I mentioned like statelessness or like Verkle and that whole line of work. There are things we can do to make the chain easier to validate, and like in the limit you even get to like ZK EVMs or things like this, where you could imagine that like what does the execution layer look like in 5 years? Well, maybe the whole thing is just essentially a snark, or at least what you're like what most users see is just a snark. So like rather than have to like download every payload and execute it and make sure that it's, you know, it's valid with respect to the protocol. You can skip all that. You can just like be on some gossip network. You can get a snark that like, hey, here's the next state root of the chain, and here's a proof that it's valid. So that's kind of like the end game of a lot of this. And then how that ties into like say this wallet use case is then yeah, your wallet just has a light client bundled in it, where then it's consuming snarks like this, and now becomes very lightweight to like validate the chain. All you have to do is yeah, download say a small proof and like the state root maybe, and then you're kind of off to the races. So yeah, super important. And I think there's like a number. So yeah, there's things kind of across the ecosystem that kind of need to happen to like get to this nice vision. But people very much are working on it, and we'll get there. So there's that. Maybe like yeah, even zooming into like today, I'd call it Helios. Helios is like a super awesome like client implementation, and I think even I saw on Twitter today or something like they're trying to reach out to more wallets and even think about integrating Helios into say MetaMask or something like this. And yeah, then you just you know sort of keep iterating and get to hopefully this like nice vision that we all have around like a super secure and decentralized Ethereum.
Yeah, awesome. That's great. Yeah, I was wondering if you bring up Helios. It's a REST client, and I think you've also contributed there, right?
A little
Yeah.
bit, yeah.
So it's great. We had it as part of fellowship as well before. We have 2 minutes. I wonder if there is some quick question. Anyone? Otherwise, I have one last quick question, then we can wrap it up. Oh, there is a question from Caleb. Vision for Ethereum. I'm not sure if that's quick, but if you can do it in 2 minutes.
Yeah, yeah, no, this is a big question that I think about probably too much. Yeah, I don't know. I guess the short answer is kind of what I was pointing out a second ago, where it's like you can imagine that like we move away from even where we are today, where it's like things are somewhat centralized, where it's like there are like to a large extent you do need to like trust some other sort of big player, whether that's a company or like something else, to actually know the state of the chain. Whereas like what I would like to see is like again this very sort of like cypherpunk vision where it's like via the application of cryptography or different things like this, you can imagine that like I have the same guarantees as these